Hi YouTube, how you doing? Today I just made this simulation which consists of primary and secondary protection of a particular load. And the purpose of this video is to just demonstrate how a primary and secondary protection work. For example, if the primary protection get failed, now it's the responsibility of the secondary protection to trip off the circuit and to save the load from getting damaged. So first of all, I will just explain the circuit of this main block, then I will get to these primary and secondary protection relays. Actually, here's my main circuit. Now the thing is that we have a three-phase source, and we have 11 kVA voltages, 50 hertz frequency, and base voltage is also 11 kVA. 11 kV, sorry, voltage 11 kV. And then we have a circuit breaker. So the circuit breaker is actually closed by default, and then the switching time is external. So this circuit breaker will be operated by this relay. And then we have a measurement block, and we are just measuring phase to phase. Now the thing is that we have just voltage and current readings, and then this voltage and current is applied to this load, which is a series load. Then wires are taken to the second circuit breaker, and then we have measurements, and according to these measurements the relay gonna get input from the current, because it is a current relay, maybe DTOC. And then we have a load, and here is our fault. Now the idea is that when fault occur on secondary protection, on load 1, series RLC load, it is the responsibility of the primary protection to trip off the circuit after 3 cycles. So wait for 3 cycles and then operate. If this protection get failed, now is the responsibility of the secondary protection to work after 6th cycle. So now zoom out. Okay, so now the thing is that I'm just giving fault at 0.5 second. So there will be no value from 0 to 0.5, and then on 0.5 there will be a step function of value 1. Now run the simulation, then I will get into this two relays circuit, how they work. And I have a power GUI, and the configuration parameters are, it is in discrete, and sample time is 10e⁻⁴. So now run the simulation. Now let's check the current of primary. As you can see, the current was flowing normal, and as the fault occur at 0.5, excessive current flows for 3 cycles, and after that the circuit is stripped. Same thing is happening with our voltages. That voltages were flowing normally at 0.5, and after that the voltage just dropped because the current overshooted. The voltage almost approaches 0, and after that they become almost like absolute 0. Now what happened to the primary protection? Sorry, a secondary protection. So here is our current graph, and here is our voltage graph. And the thing is that the current was flowing normal, and then a fault occurred, and then the current overshooted. At this time, this primary protection worked and tripped off the circuit, so this load get isolated, but this load is still getting the current and voltages. So primary protection just cut off this supply to this load, and the current and voltages keep circulating in this load. Now you can see or observe that the amount of current is from 2 ampere, 2 into 10 raised to the power 6 ampere, to almost a little less. So the idea is that as the current is flowing, or these two loads are getting current, so they are consuming more current because they're in series. So when one will get tripped off or isolated, this current will consume less current. So here I will just try to pretend that this secondary protection has failed to work. So let's just add a step function over here, and the purpose of this step function to keep the relay closed. So as far as I am getting 1 as initial and final, the current will keep energized. Or you can also put a scope over here. We'll get a straight line. It's mean that continuously power is supplied to this circuit breaker, and circuit breaker will not trip or get opened. So it is a way to pretend that our primary protection get failed after 3 cycle. Now is the responsibility of the secondary protection to work after 6 cycle and just isolate both this load and this load. Now let's run the simulation, and we hurry up complete. Now as you can see in current and voltage graph, first of all we're getting normal current, and then the current get overshooted, and then it is tripped off after 6 cycle, 1 2 3 4 5 6 and 7 cycle, because it has to just get to the 0 value to trip off this relay. And let's open the primary and hope we will get the same results of graphs, because as you can see it's 2 into 10 raised power minus 4 ampere of current was flowing, and then after 6 cycle is just tripped off. So now the thing is that both of the lows are getting isolated, so on the whole system is just collapsed. So it was just a way to demonstrate or to just visualize how primary and secondary protection work. Now let's get into the relay section. Now both of these relays are same, but they are working on different cycles. So let's get into this relay. So 3-phase supply is coming into this circuit here from current measurements, and then that is converted into RMS discrete. Now here is our conditions, because for the instance in normal condition the current is 10 raised to the power 3, which is less than our reference value 20 into 10 raised to the power 3. So as condition is true, we will get 1 at the outset, and the counter will get reset again and again. Now let's suppose that when the fault is occurred, the current is overshooted to the 30 into 10 raised to the power 3 amperes, which is more than 20 ampere over a safety value or just a reference point. The condition gets false and we got 0 over here. When we get 0 over here, the counter will not reset and start counting. And after 3rd cycle, when 4th cycle will come, 4 is obviously greater than 3rd cycle, and again the condition will come true. Now here we have to study the SR flip-flop, how it works. Now thing is that we want 1 on the output in the normal conditions, so we want Q1. So for this we have to put S and R 0. So as you can see, when the condition was false, we were getting 0 over here and 0 as well over here from the constant 2, and it was continuously Q dash was 1, as you can see over here, and all of this phase were 1, and we were getting an output which was just trying to keep the circuit breaker closed. What's going to happen when we get 1 over here on the S? When we get 1 on the S, we have set its Q on 0. Let me show you the initial state condition of Q is 0. So we have Q over here, which is 0, and S is equal to 1. When false is occurred, S is equal to 1. So 1 plus 0 in binary addition is 1, and then it is inverted. Then we will get 0 on the Q dash. When we get 0 on the Q dash, we will get 0 out over here at the output of this circuit breaker, or I would say a relay, which is now feeding the circuit breaker. And this conversion is done to just get the output in double form. So here is the counter. It is up direction counter. It will come only upward and is free running, not just actuating on rising edge or falling edge, and it is usually defined, which is approximately 1 into 10 raised to the power 6. So you can count up. Idea is not at normal condition. this circuit will produce 1, which will keep the relay energized, and as this circuit will produce a 0, this circuit breaker will open, and this cut off the supply to this load. And same thing gonna happen to this, but there is just a difference over here. Here we have 3 cycles, and here we have 6 cycles. Rest of the things are same. So that was a simulation of primary and secondary protection in Simulink, to just realize that how primary and secondary protection work. But it's just kind of a demonstration. Take care, have a nice day.